Hi, and welcome to this lecture on PEP 8 and Python best practices. So, what is PEP 8? PEP 8 is a style guide for Python code that provides guidelines on how to write Python code that is more readable and maintainable. The name PEP 8 stands for Python Enhancement Proposal 8, which is the proposal that outlines the style guide. PEP 8 provides a guideline for various aspects of Python code, such as naming conventions, indentation, line length, whitespace, comments, and more. The idea behind PEP 8 is to create consistent and readable styles that can be easily understood by other Python developers. Some of the key guidelines outlined in PEP 8 include using 4 spaces for indentation, limiting lines to 79 characters, using descriptive variable names and function names, and using white spaces appropriately to improve readability. Adhering to the PEP 8 style guide can help make your Python code more readable, which in turn can make it easier to maintain and debug. Many Python developers and organizations have adopted PEP 8 as their standard style guide for Python code. There are also several tools that are available that can help enforce PEP 8 guidelines, such as Pylint and Flake 8 and Black. So, okay, let's start off with our mission, okay, like our goal. Okay, I think we should probably, everything you do should probably break down into like what the goal is, okay? But I'd say that this is our mission as a rigger, as a Python developer. And yeah, you are a Python developer now. You are starting on your journey to automate hard tasks. And this is what I believe our mission should probably be stated as. As a Python developer working by yourself or part of a team, your goal is to create and improve features that can work with the current systems that exist in your pipeline, giving co-workers, artists, friends, the ability to work better with each other to create amazing content. So let's just look at that a little bit. Your job is to just create amazing content along with these people, but everyone has their part. Your job is to create the tools that will help them do this. This is why you're going to be paid well. And this is why people will love what you do if you do it well for them. So let's have a look at the requirements and best practices. So we may all think that building and creating features is the best way to show that we are great at our jobs. Well, yes and no. So building the correct features in the right way is actually the most important part of our jobs. Okay, this means really understanding the problems that we are facing and then addressing them correctly. So, taking this into consideration, you should understand that not everyone knows how to write code or how best to implement it. As a developer, you must sit with the relevant people, educate yourself about the problem that they are faced with and the specs that they think are required, refine these specs with them, and deliver features that are fixing the problem. Now, I can't overstate how important it is that you make sure you make time to talk to the relevant people, okay? And that means, and I'm people, plural, okay? Because there's a lot of times where I'll have juniors or animators come to me and ask for a feature, which when I then talk to them, I was actually, that already exists if you look here. But obviously where, some of the most contractors that I'm working with at this company are on contract, okay? They're maybe not used to my rigs, okay? So they need to learn about the rig first and I can run them through it. Or you want to make sure that if that's a junior animator, that you have the senior animators, because when you change that rig, it's going to change it for everyone, okay? I'm assuming they're referencing that rig in. So you need to make sure you have the senior in and they give the all clear for change to happen. Or they state, well, actually, this is how we're going to do it. You don't want to talk to that one person, spend 2 hours, 3 hours making a change, update the rig to then have the seniors come back to you and go, actually, we didn't want that. Who told you to do that? Always have a chat with people about the features. That's why I'd normally recommend maybe a 10-minute scrum in the morning or having a quick call, a 5-10-minute call to actually assess the specs of what is being requested. And make sure you get everyone involved that is going to be working with that rig or with that code. For example, if you're doing a scheduling tool for a shop grid, let's say, as a tech, your job will be to make sure you get all the producers using that tool in the room. You don't want to just use one producer that maybe hasn't used it very much. You want as many people as possible to really refine the specs with them. You should never deliver anything, well, something, but anything you don't understand and doesn't really make sense to you. It's not a waste of your time to work on this. It's actually the most important part of your job. Bonus points if you can really understand the business problem. You are able to offer the intelligent feedback and you influence the spec in a positive way. That's what you're being paid for, to help the business solve business problems that will also make the world a better place. You're going to be paid very well for what you do. Like I already said, all right, you need to make sure that what you're doing has all of these aspects in mind. You've got the right people in the room, you're talking to them, and you've got to understand the business problem. Generally, what you're doing is you're automating, you're making good rigs that can make your animators work faster. You're making tools that help everyone save time. If you're updating a rig and you make it slower and you make it harder to use, you're going to slow your animators down. That's costing your business problems. It's costing them money. It means there's less money around to give people like you a pay rise. So save money for everyone, save them time, and then make everyone's life easier so they don't have to work into the middle of the night. That's what everybody wants. I could probably say that this is the gold standard of how you should look at your planning, implementation, and verification cycle. So let's look at planning. Let's look at the software roadmap. Is the feature that's being asked, should that be done right now? Or should that be left because you've got some more important features to do? If you're going to make this feature, okay, once you start, make a prototype. Make it quickly. Make it the bare minimum that it has to be, in a couple hours or less, just to show somebody what it is if it's a small tool. Just literally just the code, just run it so somebody can come to your computer and see it. Because that is very important. You don't want to spend, 5 days, 2 weeks, just creating something as a prototype that then somebody goes, actually, that's not at all what I wanted. So make a crappy, little prototype that somebody can see and go, yep, okay, yeah, that's exactly what I want. And then put it in a UI, then do all the hard stuff after, okay? Increment, so that's it. Start off on that small point, increment, okay, gradually with the features, increasing them as you go, okay? Don't put every feature in to start with because, as you said, as I just said, you might not need them all, okay? Start off with a very simple prototype and then increment on that. Get design input after every increment. Make sure that you get everything out of there. And then for extreme scenarios, I used to do this quite a lot when I was working in double negative, and changes I made would affect everyone in the whole company, whether they were in Mumbai, whether they're in London or in Canada. It might be worth doing a risk assessment on what you are doing. For example, I essentially did a risk assessment on changing the spec and the usage of a column within Shotgun within the data that we were gathering for certain artists' time being used. We wanted to make that into a float number because it was currently just an integer. All right. I knew that this would be incredibly dangerous if this went wrong and we changed the column and anything bad happened. So I kind of said this was what would happen if it goes wrong. So I tried to mitigate against that by running small tests with small data pools, which obviously ran fine. I even contacted Shotgun at the time, I think now ShotGrid, Shotgun to say, look, can I do this? This is the data pool. This is how big this is how many cells it will affect. And this is how much essentially is plugged in. And yeah, Shotgun essentially on the call said, yep, that is fine. I even got an email from him saying that's fine. Lo and behold, I made the change and it actually crashed Shotgun, which all of our tools were running through Shotgun at the time, so we couldn't access anything. So I had to kind of call up Shotgun and go, guys, you told me that this would be fine. Okay. So they luckily unlocked the system and we were able to move forward. But, again, if I'd have just made those changes without actually getting the correct design input, doing maybe a risk management or a risk assessment on what was going to happen and letting the relevant stakeholders know what I was doing, and I did it in silence, people would have been pissed off. Actually, it was funny. I literally downed the whole of double negative for possibly 2 or 3 hours while Shotgun scrambled to try and fix the problem, which I'd caused that they'd said I could do. But nobody cared. Everyone was actually incredibly nice because they knew that I'd talked to them all about it. I'd said the risks, and I'd also said, and they also knew that I'd contacted Shotgun. They knew I hadn't just done this, out of the blue. Okay, so planning is very important, and everyone will be at ease with you if you plan. Okay, well, so implementation. So once you've got your prototype, okay, you want to do some code development on it. Okay, you want to make sure that the increment is there, that you have a version control system in place that you could save this on so that your If you ever need to go back to a version that has some part of the code that you got rid of, but you now need, you can go back. So make sure you're storing this in Git, okay? You're storing it in a code repository. And then remember, your design outputs are very important. Make sure that these do not just get implemented, that these are seen. All right, so the last stage of this section would be the verification. So write some unit tests, even if they're small, maybe some functional tests, or I'd actually probably say integration tests, maybe most importantly, to make sure the whole thing runs. Then write some unit tests on the sections. Functional tests. Functional tests are as we spoke about, these are the tests of actually users using it, okay? If you've made a really complicated tool that you understand, but it's going to be used by somebody who's not very technical, maybe a producer that isn't very good on the computer, or maybe someone who's a client who, again, not very tech savvy, you need them to test this, because you need to make this easy for them to use. They're the end user that are going to be using this. User research, as we've just said, with a functional test, it's very useful. They'll give you feedback. Take these design inputs and make sure you put them all the way back to planning and then start again. Keep on incrementing through your build. This is the gold standard. Obviously, you can cut out sections of this when you're working, but this is the gold standard. So, style guide. You should use an automatic code formatter like Black or PyLinter, as we've talked about, which are fantastic. All they do is they ensure that you've got 4 spaces on your indentation. They make sure that you have a space before and after your operators. And they make sure you don't have just random spaces at the end of your lines. These can be built in to text editors, your IDEs, and they will format your code on save. So they will do it for you, okay? You can write slightly messy code, and they will clean it up for you. So this means your code will be made as readable as possible for the next developer or yourself in 5 years when you come back to look at your code. Now, as we've said before, be explicit. Whenever you're writing, reviewing, or refactoring code, ask yourself, what does this variable represent? What can I call it that makes sense for a future reader to understand what it is? This is key to readability. Instead of writing numbers 1, 2, 3, 4, 5, def, even, return, is this divisible by 2? Is this an even number? Return numbers, filter, even numbers. This, again, it does something, but again, in the context of another 400 lines of code that looks like this, that doesn't actually have anything explaining what it's doing, this is going to drive you crazy in a few years. And the next person looking at this, it's going to drive them more crazy because they'll be annoyed at you for not making their life easier. Maybe write a list of phone numbers. Give a comment right above what you're doing. You've got a variable name, which is very understandable there. Phone numbers list. Okay, it's got underscores. It's easy to read. Equals, and then you've got your list of phone numbers. Your function here is named check number is even. So I now know what this function is doing with a very quick glance. I don't need to kind of look at what the actual code of it is doing because the function is telling me what this should do. I know that if I pass this a number, it's going to check if that number is even. But I can also call the docstring from this function. This is a function that returns true if a number is even and false otherwise. Great. That's telling me exactly what the function's doing. I've then got a comment below saying use filter to get even numbers from a list. Even numbers list. Filter. Check number is even, okay, and the phone numbers list. So again, it's a lot easier to understand what is happening here, mainly because of the clear variable names. But for extra context, we've also given some comments and docstring. So what we're basically saying is don't be clever for your own sake. You might be very clever, but context is key. And you being clever now, okay, and knowing what you're writing is not you in 5 years that can't remember what the hell is going on in this line of code. Your colleagues will thank you more for writing simple code that's easy to maintain than for using advanced features of a language unnecessarily, however impressive that might be. Out of the new feature context in 3 years' time, code can be hard to understand, and unless written well, this future developer is who you are writing for. Okay, remember that. It's not you, okay, it's the future developer that doesn't remember or has never looked at this code before. So, as we said, don't be cute. Will they know what the function named Holy Hand Grenade is supposed to do at a glance? No. Maybe in this case, use the name delete items. It might be a better name, okay? Choose clarity over entertainment. If you're working somewhere and you name everything with this Holy Hand Grenade, We're going to call this the Skyfall procedure. We're going to call this Elon Musk's kick. No one is going to know what these functions mean without then having to look at the docstring, look at the comment, look at the whole function itself, which is going to annoy everyone. But with delete items, in Maya, I know exactly what this is doing. This is going to, I'm assuming, take a list of items and delete them. It's great. I know what it does. I don't need to read any further, and I know what it does, and it'll be easy for me to search for. If I want to search my library for a delete function, I can quite simply press delete, and it'll come up. If I type in delete, holy hand grenade's not going to come up. So I am literally just going to annoy everyone. So actually, another bit of context in this. Let's say you're going to write this code. That's great. You might understand it. You might think it's fun. There'll be a point where you are going to change job, and you should look at that. When I worked at Framestore, I was approached by another visual effects company, and they offered to more than double my salary. Yeah, literally overnight, I was just like, what? Like, that can't be true. And it was just, and I was like, okay. So I went to my line manager. I said, look, they've offered to double my salary here. Like, can you match that? And unfortunately, I loved my job at Framestore. I worked on some great things, but they said no. Okay, so I took the job. So, I'm leaving that company kind of without any idea that I was going to be leaving it within the month, well, the end of that month. And if I'd have just had a whole load of functions called Holy Hand Grenade and all that, it would have just been a nightmare. You always write your code as if you're not going to be there in a month or 2 months. Write everything cleanly and beautifully, and then the future you, or the future person taking on that role, will be very happy. So comments. Let's look at comments should be kept to a minimum. If the purpose of a bit of code is so obtuse that you feel it should be heavily commented, perhaps try writing the variable names a little bit better, or break discrete actions into named functions that clearly communicate what they are doing. So before we had probably, I'd say, too many comments. I'd say that phone numbers list didn't really need a comment. I know what that is doing because of the variable name. And again, we don't need anything. We don't really need the docstring in this function, but it's a plus. We know what the function is doing because of the function name. And then at the bottom, we've got even numbers list. I'd probably even call that even phone numbers list, just to make it even more obvious that we are getting the list of phone numbers, which is even. So again, we don't need the comments. As long as you are writing clean code with obvious variable names, keep the comments down. Just write good code. Don't call phone numbers lists P and L. No one's going to know what that is. You might know what that is now, but you're not going to know what that is in 3-4 months when you've written it's another 7,000 lines of code or whatever it is, because you've been like on a mad refactoring of a whole part of your pipeline. So yeah, think ahead and make things obvious. So good comments can explain exceptional circumstances, the reason behind a necessary hack that would otherwise confuse the reader. As above, if a comment for the code is not seen later on in the code when a developer looks at X again, along with the other variables, the functionality will be easily forgotten. So, name it explicitly instead. Bad comments can confuse programmers by making them doubt the intentions of a piece of code, especially when not updated. When you're refactoring, refactor the code and the comments. Don't just leave the comments, because then you're leaving something which doesn't apply. You will literally confuse everyone. But obviously, variable names can sometimes mean that you don't need clear variable names can mean you don't need comments. So it's all again about context. So the real comments on a piece of code's expected behavior can be found in the unit tests. Okay, this is what we've looked at briefly. So these are always and should always be up to date and truthful. Otherwise, they simply won't work. Comments are the expected behavior of the entire system that can be found in functional tests, or, well, in your system's unit test. So functional tests, have we already said, is something different, so that's bad writing on my part. But unit tests are testing a specific functionality where you should have comments that say exactly what's meant to be happening. And these do comment, essentially, even with the code itself. What should this be doing? Okay, and you should have test cases that are real-world test cases within that code. So dry, don't repeat yourself. Okay, this is very important. The fewer lines of code in the code base, the better. The smaller code bases are easier to understand, easier to change, and easier to reason about. If you see 2 pages of code where each line looks kind of identical and you have to read the entire 2 pages to check that, those 2 pages should be condensed and reformatted immediately. If there are repeated blocks of code, they should be refactored into functions. And if you have a long list of calls to a function where just the argument changes, put those arguments into a list and loop over them. Look at the code base and try to figure out how you might shrink it, how you might dry it out. Code bases tend to grow over time, okay? But most importantly, they don't have to. The best example is the code we're going to learn about in this, where I refactored my code base and my nodal setup. It actually shortened everything I then started writing with it. My IK setup for my leg shortened from about, 1,800 lines of code of different modules to about 800. I literally cut my code down by more than half, okay, because I refactored the code and made it more readable. Readability counts, okay? It makes it so much easier now for me to debug. If there's ever a problem, if I want to write features, like I said, I can write 10 times less code by just having good coding practices. Further on dry. So test code may be an exception for dry. Tests need to be clearly expressed and express exactly what is being tested, okay? And we need to be sure that changes to one test will not accidentally modify the meaning of another test or render it pointless. So think twice before using utility functions such as print or length. Test fixtures such as the setup and teardown, as we looked at. These are useful, though apply judgment, okay, and make sure that they have their specific scenarios. Try not to use a setup and a teardown for too many very different scenarios, because this will just slow your test down. The rule of 3. So this may seem to contradict the principle of dry, but it doesn't really. It just softens it and makes your work less frustrating. This principle is simple, okay? Wait until you see a pattern occur 3 times before you try and generalize it. So copy that hunk of code once, but if you find yourself doing it for a 3rd time, then now would be a good time to refactor it out into a function. Some kind of reusable abstraction that makes our code easier to read and work with. This rule helps you avoid wasting time thinking too much about a simple bit of code that will never be reused outside your core functionality, or even maybe that module. Okay, if you've got a module, or if you've got a little chunk of code that needs using in one module a load of times, yeah, keep it in that module. Okay, just make sure you abstract it out into a function so it can be reused if needed. Leave the code nicer than you found it. Okay, this should be just true for all life. Just try to leave any area, any situation better than you found it. When you make a change to the code base, you should always leave it slightly nicer than you found it. If you're touching a class or modifying a function, take some time to refactor it. Add updates to the comments, the variable names, remove an unused import, restructure a conditional so that it's not a double negative. And never, ever make a mess. Everyone making small improvements can pull a code base back from the edge. Pair programming. Where possible, and not in any mad lockdown situation from any mad outbreak, okay, this will make you a better programmer, even if it is just for an hour a week. Look, sit down with someone who's more senior than you. Get them to read over your code. Even it's tough for me at this situation because I'm actually the most senior Python developer at my company, but this doesn't mean it's not useful for me to sit down with someone who's a very good mid developer. You know, I still learn things from mid developers, junior developers, or someone who's just obsessively taking in content and data at that time, because, you know, they might even remind me of something I've forgotten. It's like we've talked about with the modules that we're learning about here. There's a lot of things I don't use very often because I have better ways of doing things, or I have refined my functionality down, that I have abstracted that functionality far away from any code I need to write now. But so someone better than you will teach you how to do something better, or may have some insights, but even someone that you're just explaining something to that's worse than you, and the simple fact of explaining something to someone may make it more obvious in your mind what is happening, and make it more understandable, and make you understand it better by simplifying how it works in your own head. Testing. Our tests codify the behavior of our application. They are the best documentation for the behavior as we expect it. Okay, and they should be comprehensive. Aim for 100% test coverage. This, it's not always easy. You're not always going to have a huge amount of time for this. But the best way that I started approaching this when I started getting test framework set up in my library quite a few years ago now, was that I started off actually with the implementation testing. Okay, I started off with the very big tests. I actually just ran rig builds, and I ran the biggest functions that I could that used the most amount of code. So I ran a build that would build a biped, a quadruped, a snake rig, a facial setup. I ran the things that use huge amounts of modules within my library, because then I was getting actually up to 85% test coverage just by running those very big functions, which at least it kind of helped me to say, well, if I am making changes and these break, okay, now I can go and look at where the breaks are and fix them. So this does actually help me. It helps me massively to be ready for production. So when I had maybe a few months off from contracting and I could refactor and work on my my code base, I could then, if somebody then contacted me with a job and I'd say yes, I could quickly run my test and go, okay, yep, everything's working that I need for this job. Great, cool, and then get ready for the job. If you don't have any tests, you are quite literally in a nightmare situation where you don't know when things are going to break, and you don't know when you change something, what else it's affecting. You need to have tests. I will try to bang this into your head as much as possible, because it is, for some reason, within rigging and within visual effects, it is not seen very much. Okay, literally every company I've been to, testing is just not done. It's not something that people think about. I've been to the biggest companies in the world. I've rigged for the biggest companies in the world, and they are literally just updating their rigging pipelines, on the fly. A few of them, and I won't name names because these are the biggest companies in the world. A few of them push all their code to master on their GitHub branch. It's a joke. Like, you should never do that, but they do it because it's easier for them and they can't be bothered to make changes. It doesn't matter how dangerous it is, and how many days I've had. I was contracting one company for £500 a day. I'll tell you the money because I'm not showing off, because you are worth that money, and you will be worth that money very, very shortly after doing these tutorials. But I was surprised that I was being paid £500 a day. I had 9 days within a 9-month contract where I wasn't working because their systems were down, so I couldn't do any work for them. That's good money, that's $4.5 grand for sitting on my ass. I just had to be near my computer waiting for it to be working. So I literally just worked on my own pipeline. But yeah, I couldn't work. They paid me to sit on my ass. That was fine. I was okay with that. But yeah, I kept on contacting them asking, do you want me to can I do anything? And they're like, well, we're still trying to fix something. And they just, okay, great, fine. It's tragic, but then that's why you should write tests. That won't happen if you have everything tested. Look, so don't reinvent the wheel. When you're setting out to implement something, ask yourself, has this already been done by somebody else? You will save yourself massive amounts of time and maintenance overhead by installing a module, studying a rig, and integrating its methodology with the rest of your system, rather than trying to figure out, how to do it yourself from scratch. If your code library were nothing more than a bunch of open source libraries plumbed together, and it still did everything your customers wanted it to do, then that is a very good thing. And that's a good starting point. You do not need to have everything done your own way, because that will take a long time. It took me years to get the system to a point where I'd say it was ready for film and high-level advertising. But after a few years of creating my own system, I'd say it was better than pretty much any system I ever went to, any in-house system I used to see. And it was just because I used to apply these methodologies and I used to love it. So, like I said, most contractors and most companies don't understand what they're doing when they hire contractors, is that they're not giving someone the passion and the time to really spend and care about the systems. That's why visual effects is a love-hate relationship, I think, for most TDs. They want to get more time to actually do a better job for what they love, but they're sometimes just not. And it's, love-hate. So, Python best practices with great power, okay? Sure, some rules are straightforward, but coding is all about good taste and intuition. Just like chefs need to know the basics of cooking, a programmer needs to know the basic principles of Python to create something truly amazing. So let's dive into the zen of Python and unleash our inner coding artists. Okay, let's have a look at one other thing. Okay. So, like I said, very easily for you're going to make great money in the future. Okay, doing this. Okay, and it's not all about the money. I don't do this for the money. I do it because I love it. But your job is to essentially make everyone's life easier, and that's kind of what I do love about this. I love helping people make their lives easier. Okay, and giving them tools that makes better animations that then I can say, well, yeah, that's my rig that made that animation. Okay, that's the deformation is always then beautiful. It looks anatomically correct. Okay, you've got to remember that. I love hate. I have a love hate relationship with Elon Musk as well, because sometimes he says some crazy things. But there's no denying that Elon Musk is an amazing developer, and he has applied that mentality to his pipeline, to his code pipelines, and now to his car pipelines. So you see, they are the only car manufacturer in the world that turns huge profits from making electric vehicles. There's no one else out there that can do that. And that is only because he has implemented basically coding best practices within a physical world. He continually improves and continually updates and uses best practices with his pipelines. They don't, if they find a problem, they don't just leave it as it is. They improve it. They continually make it better. And that is what we are going to. We are trying to release our inner zen of Python. We are releasing the amazing ability that Python gives us, and we are releasing that to the world. That concludes our Python course. And thank you again. Thank you so much for listening. I know this is not an easy subject, especially if you're a beginner. This is probably a little bit overwhelming, but just make sure you take lots of notes, okay? You practice, you review, you go back over your notes, and yeah, you go through and practice a lot of these methodologies. The only way they'll become second nature to you is by looking at them every day. And you will do that in most of the jobs you have, okay? By practicing these methods, putting them into functionality that you want to make and applying it. All right, I'll see you in the next course. Bye.